All right, guys, this is the third video in the gas law chapter. And in this one, we're going to talk about volume and temperature. And if you look, what we have here is we have a scenario where you have a container and it has gas particles. The black dots are gas particles. And as we heat it, what we see is the gas particles are going to spread out. So this then increases the volume. And this is what you saw in the lab when we had the schlumpy balloon, the balloon that wasn't full with helium, and you heated it, and then all of a sudden the balloon started to look fuller and fuller, because as you raised the temperature, you increased the volume. So what we see is as the volume increases, the temperature increases. So we call this being directly proportional. So mathematically, we represent this as a volume over a given temperature is equal to a constant K. Which means if our system is closed, we can't add things or take things away from the system, and we're behaving as an ideal gas, that if I take volume and divide it by the temperature, it will always be some value. Now, we said for Boyle's law in the last chapter, we had, I'm trying to decide if I want to write this because I don't want to confuse you. We had P1 V1 equals P2 V2. Or we said we had pressure times volume equals a constant. And we said if variables in a linear equation, if variables are on the same side of the equation, they're indirectly proportional. But in a linear equation, if variables are on opposite sides of the equation. Whoops, opposite. It's an E. Fix that. Opposite sides of the equation. They are directly proportional. They are directly proportional. Well, you might be saying these aren't on the same side of the equation, but I told you they were directly proportional. Is this a linear equation? Linear equation means it's in a line. So if I multiply this side by t, I get V equals K times T. And do we see now that these are on opposite sides of the equation? So as this goes up, this is going to go up. As this goes down, this goes down. The guy who discovered this was, his last name was Charles. So this is known as Charles' law. And Charles' law says that volume and temperature, basically says volume and temperature are directly proportional. And we write this as V1 over T1 equals V2 over T2, where temperature has to be in Celsius. Oops, I'm sorry. I meant to write Kelvin. I meant to say it's converted from Celsius. So your temperature must be in Kelvin. Let's just make sure that Celsius is crossed out. So you have to convert your Celsius to Kelvin. Now I told you guys it can be tricky to remember Boyle's law, Charles' law, and Gay-Lussac's law, the third one we're going to do. So I like to remember that Charlie Brown, you guys know the cartoon Charlie Brown. How many of you have heard of DirecTV? Now it's kind of going away in time, but DirecTV is a cable provider, So if you had DirecTV, you might be able to watch the Charlie Brown Christmas special. So the sentence that I use to try to remember Charles' Law is that Charlie Brown is a direct TV special. So our takeaways there are that with Charles' Law, we're saying that temperature and volume are directly proportional. And again, remember, that's going to be a big slice of the test, is understanding the proportionality between them. She got moved. So let's do a sample problem. So if I start off at 25 degrees Celsius and a volume of 1.3 liters, what will the final volume be, or V2 be, at 62 degrees Celsius? Well, first of all, I have to convert my temperature to Kelvin. So I'm just going to, one of the things I like to do is before I make my variable bank, I'll just convert my temperature. So if I add 273 to this becomes 298 Kelvin. And 62 plus 273 is 335 Kelvin. So I'm going to make a variable bank. I've got V1, T1, V2, T2. So I've got 1.3 liters. I've got 298 Kelvin. I'm solving for V2, and T2 is 335 Kelvin. So I'm going to put that into my equation. I've got 1.3 liters over 298 equals V2 over 335. The easiest way to solve these is to cross multiply. So I'm going to take 1.3 times 335 equals V2 times 298. And when I solve, 1.3 times 335 is 435.5 equals 298 V2. So that's going to give me a volume of 1.46 liters. 1.3 times 335 divided by, just double check my math there. Yep. Okay. So again, our takeaways here are volume and temperature are directly proportional. As one goes up, so does the other. Charles' Law is what tells us this. Temperature has to be in Kelvin. So we did a sample calculation over here. And if you want to remember it, you can remember that Charlie Brown is a direct TV cable provider, DirecTV special. And hopefully that'll help you keep this relationship in mind. Okay, that does it for Charles' Law. On to the next video where we talk about Gay-Lussac's and combined gas law. Thanks for watching.